All right, so 3, 4. You'll notice we did skip 3, 3. 3, 3 is a section that is no longer an Algebra 2 standard. It's actually moved to a trig pre-calc standard, so you'll get that next year. So 3, 4, dividing polynomials. It's one of these really obvious learning targets. The goal is I can divide polynomials. So that's what we're going to be able to do after we're done with this section. So there's an example here that talks about my boy Benson and essentially what we did in the warm-up, taking a value and doing the long division to figure it out. So he said, okay, 6 goes into 8 one time. So he subtracted the 6, got it down to 23. He said 6 goes into 23 three times. So 3 times 6 was 18. Took that away and had a remainder of 5. So same concept as what we talked about. Things to keep in mind. There's some terminology here that you're going to hear a lot in this section. So this number is called the, it's an R. It's called the divisor, not division, divisor. This number is called the dividend. And this number is called the quotient. And the R for remainder. So you take your dividend, you divide it by the divisor, and that gives you the quotient, and sometimes there's a remainder. That's how all those words play together. All right. I'm not going to go through and answer these questions too much, really, other than this fraction part is key, is recognizing that whatever your remainder is you're left with 5 because you said, like, I couldn't divide 5 by 6, but as a fraction, that is 5/6. And that's why, like, if you did 83 divided by 6, 83 divided by 6, 83 divided by 6, you get 13.833333. That's because 5/6 is 0.83333. Okay, so that's like the logic of it is whatever you're left as your remainder, you can just write as a fraction. So this same answer can be written as 13 and 5/6 as like a mixed number. Okay. All right, so with that said, let's get into polynomial long division. So this says, how can we use long division to divide this p of x? So you got this big 4-term polynomial here, and we're going to divide it by d of x, this x plus 3. Write it in terms of the quotient and the remainder. Okay, so we are going to set this up the same way. I think I'm going to do it right here, where there's kind of good space. So this is our divisor. So we're going to put that on the outside of our little long division bar, which it's not little. It's going to have all this under it. And then we're going to write this and make sure everything's in standard form. Most of these problems will already be in standard form, but if it wasn't, always reorder it so that it is. All right, so this looks exactly like what you would do with numbers. Nothing different, nothing weird, nothing at all. So here's the process that we go through now. Is you're going to always be dealing with your lead term. Okay, sorry, lead term here, and you're going to kind of go down the line just like you do with the digits of your dividend. So if I look at this, I have x, and I say, how many times does x go into x to the third? Or in other words, like, what would I, sorry, maybe that's not the best way to say it. What would I want to multiply this by, x by, in order to get an x to the third? In which case you'd say, oh, I would need to multiply this by an x squared. Because x times an x squared would get me an x to the third. So you're kind of thinking of what would I need to multiply by? And in that case, whatever that is, you're going to write up top. And then, just like what you do with up here, you take that x squared, you multiply it by this, you write it below, and you subtract it. So I do x squared times x, that's x to the third, and x squared times 3, that's 3x squared. Then I subtract that. Now, you are subtracting it as a quantity, and this is just like what we did with adding and subtracting. So the x to the third minus the x to the third, that's going to be nothing. Those are going to, eliminate each other. So you can draw through it if you want to. 5x squared minus a 3x squared, well, that's 2x squared. Okay. And then go ahead and bring down these other parts. So we have the 6x and the 9. And we're essentially going to just keep repeating that step we just did until we can't go any further. So on to the next one, we'd say, if I have an x, what do I need to multiply by x by to turn it into a 2x squared? Well, I'd have to definitely multiply it by 2, and I'd also have to multiply it by an x. So that means my next term is going to be 2x, because 2x times x gives me 2x squared. So it's sort of like you're filling in the blank. You're saying x times what gives me this. All right, so now take your 2x and multiply it by this. Again, the first term should always match. You've designed it to do that. And then 2x times 3 would be a plus 6x. So we, just like last time, are going to subtract it. I would really recommend setting it up with parentheses like this. It's going to help you remember that, okay, I need to subtract both terms. So 2x squared minus 2x squared obviously cancels out, but also 6x squared, or sorry, 6x minus 6x also cancels out. And so we're just left with 9. And at this point, it should be pretty obvious. I can't take x and multiply it by anything and get a 9. That's not going to happen. So this is now my remainder. And so the way we write the remainder is we almost always want to write it in fraction form, although sometimes it'll just ask you what the remainder is. So you have to kind of write the problem. So in this case, if you want to write it as a fraction, it's going to be 9 over this value, 9 over x plus 3. Okay. Now, sometimes it'll want you to just say, hey, this is the quotient and 9 is the remainder. That's the other way to write it. So if you were doing that, you'd say, okay, my quotient was x squared plus 2x. My remainder was 9. That would be the other way to kind of represent your answer there. So this would be writing it in sort of full form. This is, my quotient is this, my remainder was that. Both are saying the same thing, just in different formats. All right. If you're feeling all right, go ahead and try to do this one. If not, you can follow along as I do it. But if you feel like you think you can do it, pause it and see if you can. If not, I'll do it. So same setup, 2x plus 3, 8x to the third plus 27. Okay. So we look at it, we say I have a 2x. What do I need to multiply it by to get it to this? Well, I'd have to multiply it by a 4, because 2 times 4 would give me the 8. And I'd have to go with an x squared, because x squared times x would give me an x to the third. So that's what I'm going to have to use. Okay, so go ahead and multiply it out. So we're going to get 8x to the third and plus a 12x squared. And we're going to subtract those values. So those cancel. So there's no x squared term. So we basically have no x squareds minus 12x squared. So that's going to give us a minus 12x squared. And we still just have this plus 27 that we haven't done anything with yet. And I might run out of space here, but we'll make it work. Okay, so now I move on to my next round. So 2x times what gives me a negative 12x squared. So I'd have to go negative 6, because that would give me the negative 12. And then just an x, because x times x gives me x squared. Okay, so minus, that'll be negative 12x squared minus 18x. Okay, same thing. So the 12x, negative 12x's squareds will cancel. I have 0 x's minus a negative 18x. So that's going to become a positive 18x, like so. And again, I just brought my 27 down. Haven't done anything with that yet. And then one last time, I have a 2x. How do I get it to an 18x? I would have to multiply it by 9. And when I do, I'm going to get 18x. And 9 times 3 is going to be 27. So something cool happens here. You'll notice when I subtract those, they both completely cancel out. And this problem has no remainder. Which happens. Not often, but definitely happens sometimes. And in this case, we've just this problem just has a quotient. This is the quotient. The remainder is 0 or nothing. All right. That's it. That is long division with polynomials. It's not super easy. Well, sorry. Let me take that back. Once you get it down, it is pretty easy. But it's also really easy to make an error. If you mess up one sign, if you at one point, if you're right here and you go minus this and you accidentally write this as a negative 18, well, now things don't work out. So you have to be very careful with your signs. Hands down, the most common mistake I always see is with the subtraction step. You have to make sure you subtract both values. You're subtracting the negative 12x squared and you're subtracting the negative 18x. Be really careful with your signs as you're working through those. Okay. So we got a few more examples here just to kind of run through them, and I'll do that. So this is our divisor. So we're going to have this x squared minus 4x plus 3 on the outside, x to the third minus 6x squared plus 11x minus 6 on the inside. Alrighty, so if I have an x squared, I would need to multiply it by an x to make those match up, and then distribute it. So x to the third minus 4x squared plus 3x. Make sure we subtract this whole quantity and see what we're working with. X cubes are gone. A negative 6 minus a negative 4, that's going to be a plus 4. So negative 6 plus 4 is going to be a minus 2x squared. 11 minus 3 is going to be plus 8x. And go ahead and just bring the minus 6 down. And move on to the next step. So at this point, x squared and x squared already match, so all we'd have to do is multiply it by a negative 2, and then see what happens. All right, so negative 2x squared plus 8x, ooh, that's nice, and minus 6. So what we see here is what we just saw in the last problem, where everything is identical, and this problem has no remainder. Okay, so this has just a quotient. Cool. All right, so that's it for that one. We got one last one on here. This one I think is a little bit cute. This is one that I think also works out kind of nicely. Well, sort of nicely, you'll see. So we got our divisor, 4x squared plus 9er. We got our dividend, 16x to the 4th minus 85. All right, so 4x squared, what do we have to multiply it by to get a 16x to the 4th? So we definitely have to multiply it by 4. 4 times 4 gives me the 16. And we got to have an x squared, because x squared times x squared gives me x to the 4th. Cool. So let's multiply that out. So that's going to give me the 16x to the 4th. It's also going to give me a plus 36x squared, which you notice doesn't have any like terms up there. So you have those cancel. You have no x squareds minus 36x squared. So that's minus 36x squared. And then go ahead and bring the minus 85 down. Ooh, we're short on space, but this will be the last one, so I think we'll be okay. So if we have an x squared, we have an x squared. So all we have to do is multiply this 4 by negative 9 to get it to match up. So negative 9 gives you the negative 36x squared. Negative 9 times 9 is a minus 81. And then we subtract this quantity. So those cancel out. Then you have negative 85 plus 81, which leaves us with just a remainder of 4. Of negative 4. Play careful with the signs there. So at that point, we know our remainder. We can put it on here as minus 4 over 4x squared plus 9. Okay. Boom. That would be our solution. All right. You got to try these out. That's the real key to this stuff is, you're going to see these on the assignment, obviously. You got to work them out. If you want to see other videos and stuff, if you YouTube long division of polynomials, there's probably, 1,000, probably more than 1,000 actually, videos like this. So, if you still feel like you're really struggling, check them out.